So, why are we interested in beaches? As anyone who has spent a day by the seaside knows, beaches are important tourist attractions and vital to the culture and economy of the communities that border them. This is most definitely the case of this beach here in Croatia. Moreover, beaches like this are also important to coastal communities in other ways, acting as a first line of defense for the land adjoining the beach. The sand, gravel and other material on the shore soaks up the energy of waves, reducing their power or even stopping them completely before they surge onto the cliffs, seawall, or in severe cases shoreline infrastructure such as roads and houses.
Croatia's coastline is predominantly steep and rugged, formed from carbonate rocks. It is broken up by small pockets of gravel beaches that are tucked away between headlands. They are formed when flowing surface water deposits sediment at the coast, with some additional material supplied by rockfalls and rock weathering. A small number of parts of Croatian coasts are formed from softer rock and are especially vulnerable to being worn away by wave action.
Like across much of the world, Croatia's beach is under increasing pressures both from nature and from human development. Natural pressure, such as increasing storm intensity and frequency, increased coastal flooding from storm surges, and even large waves called meteo tsunamis here in Croatia, are all contributing to coastal erosion. Critically, these events are all projected to intensify in the coming decades as a result of continuing climate change and sea level rise.
Around 20% of Croatian coastline has been subject to human development or is currently planned for new construction, a trend that is increasing with booming tourism. However, building new roads and houses along the coast can disrupt sediment supplies, and that affects how beaches are formed and maintained. In addition, these new constructions are often accompanied by the construction of protective seawall and the river canalization, all of which also affect the survival of our beaches. Even planting shrubs, something that might seem beneficial to the local environment, can reduce runoff and affect the amount of sediment material supplied to the coast. And if the amount of sediment that reaches the beach is less than the amount of sediment being eroded away by the wave action, then that beach is going to shrink.
So, what can we do about this? In order to manage a healthy beach, we first need to understand the processes that are affecting it, and this can only be done through long-term monitoring. This allows us to see how the beach is changing spatially, where the change is occurring, and how the beach is changing temporally, when and how fast the change is occurring. We can then link this information with the other data, such as the height and direction of waves, to understand why these changes are happening. This allows us to determine the best practices for action for beach management.
There are various techniques that have been developed for beach monitoring. Traditionally, we use beach profiles using survey equipment as GPS to measure height of the beach at certain location and at different times to see how it is changing. However, this is the time-consuming process that only gives us information about elevation along the few lines, rather than a whole beach. In the rocky pocket beaches of Croatia, most of which are surrounded by the steep headlands and slopes with limited accessibility, even getting the equipment to the beach can be a challenge. We therefore sought an alternative.
We decided to use a technique called SFM MVS, which stands for Structure from Motion Multi-View Stereo. This method creates 3D computer models that represent surfaces based on a collection of photographs. Importantly, it is based on images that can be taken using an ordinary digital camera, so there is no hefty or expensive equipment required. For a typical survey of Pocket Beach, we will collect several hundred to 1,000 images. A reliable 3D model requires images taken from multiple angles that overlap and converge with each other. This can sometimes involve quite a bit of scrambling around the rocks and cliffs to find the best positions. We also need to be wary of things like lighting conditions. Strong shadows and glare from the sun reduces the quality of our models, while a high tide will mean much of the beach is covered up, so we are unable to measure it. Glorious sunshine and waves lapping at your feet may be ideal conditions for beachgoers, but not for us. Once the images have been collected, we process them using specialist software to produce the models, which we then analyze. By collecting imagery at multiple times, like after storms or seasonally, we can compare different models to see where and when the beach is changing. Typically, out measurements are accurate to within a few centimeters, so they can be used to detect even quite small-scale changes.
So, how we know for sure that beaches have changed? From the models, we can measure changes in shoreline position. For example, we can determine whether beach width has changed over time. We can also look at beach volume and beach elevation. From this, we can determine how sediment is moving at the beach and if any action needs to be taken. These days, this often involves adding sand and gravel to a beach to replace the material that has been lost in a process known as beach nourishment. What have we learned? We have carried out monitoring at 2 beaches in Croatia using these structure for motion techniques at Ruzic on the western edge of Kvarner Bay and Dugi Rat in the middle of Dalmatia.
Ruzic is an interesting case. We found that beach rotates with material being eroded away from one end and deposed on the other, depending on the direction of waves, with the position of the shoreline changing up till 8 meters on this narrow beach of 10 meters. These are dramatic changes, but we also found that while there might be losses during the storm event, the beach recovered during the period of calm weather. This could explain why the beach here has existed for such a long time and does not need any intervention.
Dugi Rat is an artificial beach and is nourished every year with new material. However, we found that this nourishment offers a limited help to the beach. Over a year and a half of monitoring, we detect continuous erosion and we saw how sediment moves around the beach in response to wave action. For example, during Sirocco waves, which come from the southeast, we found that material moved from the southeast to the northwest. We also found that the material that remains on the beach after erosion is far coarser than the sand being added during the nourishment, suggesting that the finer sediment is being eroded away faster than the coarser pebbles and cobbles that occur naturally. This will be useful to inform where to put a new sediment in the future and which properties the sediment should have.
So, what next? Both of our studies show that there can be large changes in beach morphology in both the short and long term. By monitoring and analyzing these changes, we can make suggestions for effective beach management, including best practices for beach nourishment. The low cost and high accuracy of measurements produced by structure for motion surveys means it has great potential. By applying and continuing to refine the technique at different sites, we aim to create a data archive that can be used to support Croatia's rapidly developing coastline as policymakers and practitioners develop increasingly sophisticated science-based management strategies.